Hi, today we are going to talk about lesson 6, and we will be dividing using partial quotients. So partial quotients is very similar to when you think about partial products, but with division. Breaking down our answer into pieces, seeing the place value. This is different than any other method that us adults learned in school, because long division, which is what we learned, is taking out all place value. We will eventually graduate to that and master that in 6th grade. But here in 5th grade, we are going to use those place value concepts in order to understand where each digit is going and how it functions with the divisor and dividend. So let's start with a story problem, because that's also going to be another main focus with our understanding with division. It's not just the numbers, but also seeing when that is being used in a story problem. So as you remember, with a story problem, we are going to mark it up as we go. I always call it marking it up, because how you mark it up, it depends on you. Circling, underlining, boxing, what works for you to identify the important pieces of the story problem. So example 1 here, there are 345 5th graders enrolled at Wilson Middle School and 15 5th grade classrooms. How many students are in each each class has the same number of students? So I can tell that we are taking all of these 5th graders at the middle school, and we are dividing them into 15 classrooms. It's important to understand what each of these numbers is representing. 15 classrooms, 345 5th graders. Because also think about the concept of what's actually being divided, and does that actually make sense? We're not going to break up the classrooms and give them to the kids. So of course we are going to take that 5th graders and we're splitting up the students into the classroom, because we want to know how many students, and that always helps us with our label and understanding what our answer is actually asking and representing. So with partial quotients, we are going to set up our division sign like this, and this number 345 is our dividend inside the box, and our 15 is outside, it's our divisor. Now we are technically trying to see how many 15s we can get out of 345. And using our number sense with these values, we can help our first chunk being pulled out. Now, if we were younger children, we could take those individually, piece by piece, and separate them into groups of 15. But when we have larger numbers, like I said, we can use that understanding of our number sense in order to take larger chunks at a time. So we want to take the largest possible chunk out. And what I always recommend is start with your mental math. So 15 times 10, always starting with 15 times 10. This is going to help us know if we're going to go down to 9, 8, 7, 6, 5, 4, 3, 2, or 1. And if it's actually not enough, then we can know we're going to jump to 100. And then we're working in the 90s, 80s, 70s, 60s, 50s, 40s, 30s, 20s, and so on. So it kind of gives us a good starting point. And as you get better with your number sense with this, you'll be able to do that mentally. So I know 15 times 10 is 150. We have the easy 15 times 1, and we know that 0 holds a place value, so 150. That's pretty close. Always, 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 always go over, though. So what I like to do is to check to see if I can get a bigger value so that I don't have as many partial quotients. So 10 worked, and I'm going to still use that little value to use a mental math problem. So 15 times 2 I could do mentally. 15 twice is 30, right? And if I put that 0 on, like we've talked about and learned, then it's 300. So 15 times 20 is 300. Good thing we went over because that worked. Now, I still want to go over, and it probably will go way over, but I still like to test and say, okay, now 15 times 3. Now I'm actually setting it up this way so I can see my multiplication instead of doing repeated addition. All of these I could do mentally. So 15 times 3, and then we get 45. And if you can do that mentally, still put it here, list it here. But then I just keep my work down here. Now I put that 0 there because I'm technically going to think of this as a 30 times 15. So I kind of just added those extra zeros. This is confirming that I can't take 30 groups out. 20 is my best bet. So I'm going to take, and with partial quotients, once you find you did all that thinking first, otherwise you're just going to sit there and stare at the problem and do some random guessing, is I'm going to take my 20 groups of 15 is 300. So I'm going to take that out. And I'm doing some color coding here for you so you can kind of see what's left in which step. Oh, okay. So I have 45 left. Let's think about the understanding what's happening in the problem here too. So we had 345 students. We put them in groups of 20. Now there's 45 students still waiting to get into a classroom. So we still want to keep grouping them by 15. So we are no longer looking at this work. We're looking at the 45. What's nice is I already technically thought about something that has a 45 or really close to it. Even though those zeros are there, I know 15 times 3 is 45, so I can simply do 3 groups of 15. It's 45, and then I have nothing left over. Now, in order to finish our problem, because we know with division we want to have nothing left over, they're all grouped. All these kids are in a classroom. Sometimes there could be remainders, but not in this situation. So we want our partial quotients to be stacked up at the top. I know in 4th grade you might have put them over on the side and stacked them that way. We're getting closer to using long division. So we want to put our final answer up at the top where eventually it's going to go with that method of long division. So our answer is 23. 23 what though? What were we talking about in the problem? They wanted to know how many students were in each class. So we are going to use students as a simple label. Okay. So always start with 10 and then even jumping to 100 if needed, and then finding that just right amount to start your groups. So let's try that with another problem here. A grocery store only sells eggs by the dozen. There are 12 eggs in 1 dozen. How nice. They gave us that hidden number. If there are 624 eggs in stock, how many dozens of eggs are there? Okay, so we have a total. If we always start with the total, that's going to help us know what's being divided. We have 624 eggs, and we're putting them into the dozen cartons, which are going to be groups of 12, okay? Both of these items are similar in concept. So 624 eggs, 12 eggs. So the question's asking, though, how many dozens of eggs are there? So this is really talking about like that carton that holds a dozen. So let's set up our problem. You may have noticed that when I set up this problem, I gave myself lots of room for my quotient up at the top. If you start your division up here, you're going to be into your problem and get real messy. I also suggest to some students to use graph paper so you can stay organized in your place value. So what's being divided is always inside the box. It's our dividend. And how many groups we're making is, or how many are in each group is 12, okay? And so we are all set up to divide, and what do we always start with? We always start with a 10. So 12 times 10 is 120. Okay, well, I could make 10 groups, but now I'm going to jump. I want to show you, what if I used 100? Okay, I'd have that 12, and then how many zeros? Okay, that's too big. I confirmed. So if you're ever not sure, I just confirmed that I'm working in between 10 and 100s. And I'm not using 11 or 12 or 13. The whole point is to do mental math. The whole point is to be able to take these out into mental math chunks. So I'm going to start with 20, but I know that 12 times 2 is 24 mentally, and then I can put that 20 in as 240. Okay, I'm still pretty far away, right? And just for sake of showing that sometimes you do need to really test these all out, 12 times 3 we know is 36. Now I'm getting closer, but because it's a 30, I put on my 0. All right, let's try 12 times 4. 12 times 4. And again, just like I did here, if you can't do that mentally like I am with the 12s, write it out and actually stack them. So that is 12 times 4 is 48, but I know I'm doing 40, so have that. What's nice about having these listed too is I'm going to keep taking chunks of 12. I'm going to use this over and over again as I keep dividing more and more pieces. So 12 times 5, let's do that one. That one's going to be 60, right? And so that's, because it's, I'm at 600. Again, I always go over. It's going to help me see if I maybe multiplied wrong and just confirm that I have everything that I need. So with this one, I'm actually going to stack that and see it visually get multiplied. So 12, carry the 1, 6 times 1 plus 1, 72. So because I'm working in the 60s, I put on that 0 for 720. Yeah, it is too big. So I am going to use that 50. So with my first partial quotient being 50, I stack that on the top. Notice that I'm stacking them by place value as well. I can't just put that 5 and 0 anywhere. Everything's in the correct spot. So we knew that that was 600. I'm going to take away 600 eggs because we have 50 cartons right now, and it would be 24 left over. Well, in mental math, we can do that too, but we can also see that we did that already, that the 2 times 12 equaled the 24. So we know it's not going to be 20. That'd be too big, so we're just using the 2. In 24, we have nothing left over. Our final answer gets stacked up at the top. See, I put that line to kind of put it all up there. And this is where it's important to stay in that correct place value. Otherwise, you're going to add those together incorrectly. So 52. Okay, nothing left over. 52 what? 52 dozens of eggs. It would be even okay to say cartons here because we all know what that is referring to, is that a dozen of eggs is in that one carton. Okay? So seeing this work is going to be crucial to knowing your different partial quotients in order to get your final answer. Let's try some more. So marking up this problem, an elementary student has 1,134 seeds. The seeds will be planted in 24 rows. Okay. Each row will have the same number. Okay, so they're going to be grouped evenly. How many seeds will be planted in each row? So for this problem, I want you to get it all set up, 1,134, and we're dividing it by 27, so we're making 24 groups so we can see those seeds. I want you to pause for a second and give this one a try. Now remember, so if you were here in the classroom, I would say, remember, what do we always start with? What do we always start with? We start with 10, and sometimes then even have to try 100. So pause it and give it a try. See how far you get before you're really feeling uncomfortable and want to check in with me, and then continue playing, and I will walk through this problem with you. So give it a shot. Okay, so you did 27 times 10 and got 200 70. Oh my gosh, that's so far away. It's not even going to touch it. This might be the time where, yeah, we got to jump to that 100. And 1 times 7, 27. How many zeros falling into place? 2,000. Okay, so we know that's still too big though. That means we're working still with 10s, 20s, 30s, 40s, 50s, 60s, 70, 80, or 90. Because if we get to 100, it's too far. Now, I'm even going to do some estimating here that if 100 got me all the way to, closer to like 3,000, I know I'm not going to start with a 20. That's going to be way too far away still. So I'm going to do some kind of guessing and checking. I'm going to jump to, I don't know, like 27 times 5. Now, if you did start with 20, that's fine. It's just maybe a longer process. Use those understanding about basic facts and kind of where it's going to fall, that number sense, right? All right, so 7 times 5 is 35. 2 times 5 is 10. 10 plus 3 is 13. Now, remember, I'm working with that 50 instead. Okay, so that's still over. I'm in the ballpark though. I'm getting closer. I'm a couple hundred over. So now let's try what? It's 4. So 7 times 4 is 28. 8 times 4 is 2, or 8 times 2, or 4 times 2 is 8, and then plus 2, 10, so 110, but it's a 40, so okay, that worked. Now what's nice is that I already went over. I know for sure that 40 is what I'm going to start with. So here is my 40, and we figured out that it's 1,080 that we are grouping. Let's see how much is left over. So we got to remember our borrowing here, and because I cannot take away from 3. So now I have a 13, and that's going to give me 5, nothing, and nothing. So just my 54. Okay, we can still make some groups. Let's look back at some of our work that we have to see if we can use it. So I know, okay, 54, I can't even use a 10. So now I'm working with 1, 2, 3, 4, 5, 6, 7, 8, or 9, because 10 is going to be too big, that 270. I can't do that. What I can do is kind of look at my 5. All right, times 5 was 135. Times 4 was 108. I mean, I guess I'll try a 3. So 27 times 3. All right, so 7 times 3 is 21. 2 times 3 is 6. Plus 2 is 8. Still too big. Now, I didn't put the 0 in this time because I'm not working in that range of numbers. So let's try 2. It's got to be 2 because 1 would just be 27, right? Let's see. Oh, yep. So 7 times 2 is 14. 2 times 2 is 4. Plus 1, 54. Now, it doesn't have to always work out evenly. This just did. And so even though you might have some leftovers, know you're still in the right range. So 2 times 27 is 54. Nothing left over in this case. Our final answer stacked up at the top. See what I mean by if you don't give yourself enough room, you could end up being in the problem. You don't really always know. So I always try to kind of put it in the middle when I start my problem. So 42. 42 is our answer. 42 seeds. From my marked up, I found it quickly. 42 seeds are in each of those rows. Awesome. How'd you do? So did you start with 10? Did you even try the 100? Maybe you jumped right into trying different 20s, 30s, 40s, 50s, and 60s, all the way in there. Remember, you're only trying really mental math pieces. That's why it's partial quotients, right? They're part of the final answer, that quotient. All right, let's try this one. I'm going to read it and mark it up, and then I want you to give it a try again, okay? And then check in with me, continue pushing play, or press pause and then push play to see how you did. Nathan writes an essay with a total of 583 words. Every line of his essay has 11 words. How many lines long is Ethan's essay? So our total is 583 words. If every line has 11 words, we're splitting these up into groups of 11. All right, let's set up our problem. So 583, we're dividing that by 11. All right, go ahead, pause it and give it a try. Let's see some of your work. Let's find those pieces and parts that we might need to still work on. Okay, so you tried 11 times 10. You should have, and that's 110. Okay, I'm not quite to 500. All right, let's well, I know 1 times 5 is going to be a 5. So this is where I'm saying use those place value concepts. So if 11 times 5 is 55, I made a big jump because I know that these basic facts, right? And if I did 6, it would definitely be over. That would be 66. So consider that when you're doing some of your attempts and how much you could jump. Well, what's logical, right? So I'm definitely going to go with 50 here. And remember, I didn't try 51 or 52 or 53 or 54. That's not mental math. You're just guessing and checking and doing much more multiplication work than needed than taking these large chunks out, okay? So 50, that was 550. And I am going to have 33 left over. Nice, easy mental math problem. We know 11 times 3 is 33. So I have a 33, nothing left over. I have my final answer of 53. And what are we actually talking about? Putting our answer on the line. 53. Oh, I didn't mark up my question. How many lines? I had to reread it to figure it out. Shows how important it is for quickly getting back to our answer. How many lines long? So it's 53 lines. All right. How'd you do? So these are our notes doing these problems together. Now we're still going to probably be in an uncomfortable position as we work through our practice. It's called Just the Digits. So we took out the story problems so that we can focus on the process first. So we are going to do 8 different problems. And I want to check this along the way. So if you are at home working on this, it is on Edge Elastic. If you are using Scratchpad, that is fine. And that way I can see your work before the next day. If you are using paper, that's even just probably more familiar and better for you as you start this. You can use a scratch piece of paper, write down the numbers as you go through Edge Elastic and number your work and put in your answers into Edge Elastic and say yes that you showed your work, but video message me this work so I can see how you're going. I want to see your attempts. I want to see how you're stacking. I want to see that if we were doing story problems, I would maybe even want to see that if you had it on the paper, okay? So I am looking for lots of different things. If you have questions, though, I am here. Don't forget Zoom is an option throughout the day. All right, good luck.